Hello everyone, I am Monica Miyama, a software engineering student at Makerere. I'm going to take you through my AI project. My AI project is based on fashion and it helps us to avoid ill fit. A number of people are ordering clothes online and it's the trend today. It's so heartbreaking to order this fancy dress for dinner and the delivery, it actually doesn't fit you. It's a huge problem to both the customer and the fashion designer. The customer, they may never order clothes from your platform again and may actually return it. After returning, this could cost the designer about 35% of the total cost in order to redesign the cloth to make it fit the customer. So this is really frustrating and no fashion designer would really want to go through all this. How artificial intelligence is going to be able to help solve this problem majorly by taking data from the customers. We're going to have a system where a customer can be able to enter their data. We shall have a model where it directs someone on how to take their measurements. These measurements are going to include the hip line, the bust line, the XL, the short sleeve, the long sleeve, and they'll be able to take these measurements and then they'll be able to put it into our system. They'll also be able to take photos of themselves and send it into the system so that the system will be able to look at the photos and generalize them, be able to determine the size of the customer. The data that will be needed for our system is going to majorly be digits. Digits are going to be in terms of the numbers, the size that you're going to have, they may be inches or centimeters. For example, the hip line, the bust length, the short sleeve, the long sleeve, the waistline, and many others. So we shall also get the images from the customers, and this will be able to determine like the size. We shall be able to correlate between the input and the images that the person has sent. So we have the differences between supervised learning and unsupervised learning. Supervised learning is majorly a type of learning, machine learning, where a model is trained based on categorized or labeled data. Labeled data is where data has been categorized into a certain category. You may have A and B. This A and B is categorized based on different characteristics that fit in that category, and B also on the different characteristics that fit in that category. And supervised learning is the type of learning where model is just given data and it trains itself to find similarities among the data and it classifies the data by itself. So the supervised learning techniques, we have linear regression. Linear regression is the technique where a system is able to establish a linear relationship between two variables based on the line of best fit. Here, the customers will be able to put the input and then we have the images. So we shall be able to consider the input value that have been put and the images so that we can see where really the image is giving us the right value or not. Then we have the decision tree learning technique as also a supervised learning technique. This technique is employed to visually represent decisions. It has branches which represent observations and leaves which represent conclusions. This will be used in my system to predict the size, age of the clients, and based on their input variables. Then the unsupervised learning techniques, we have the k-nearest neighbor. In this technique, the unlabeled data set is categorized into several clusters, which must be of similar properties. It's then assigned the new object to a class common among its k-nearest neighbors. It can be used to classify a person's size based on the images sent. That's how it's going to be used in my project. And then the other technique of unsupervised learning is anomaly detection. Anomaly detection is majorly used to detect irregularities or uncertainties in a system. For example, you may be having data being fed in by 6-year-old kids, and then with this data you have a size, but there comes the 6-year-old kid who has the body size of someone who's maybe 15. So that will be an anomaly because in your range you don't have it. Then the AI challenges likely to be faced in my project are also most likely to face the problem of bias. So no, much as many people order, many people may not be able to give us out their information. And based on the people that are going to give us their information, some may be only ladies maybe giving their information. And this is going to be biased in that when you get more ladies than men, than gentlemen who are giving data, or when you get more children than adults who are giving their data, the system is going to be biased so that in case someone else comes in who is maybe not in the category that you have been receiving, their information that we may be able to categorize them may not exactly be accurate as we expect. Then the other problem that you're going to face in our system may be human errors due to measurements. Normally, when you're taking measurements as fashion designers, someone has to be erect. They have to stand upright. So in case someone is taking their own measurements, they will be bending, and the data that they will put into the system will not be correct at all. And with the system, garbage in, garbage out. So when you give a system wrong data, that means the results are also going to be wrong. So we are going to overcome this problem by majorly the problem of bias. We are going to try as much as possible to make sure that we have all different categories of people giving us data, either children, the girls, the boys, the ladies, the gentlemen, the old and the young, all should be able to give us data. And data should be based on the number of varieties, not only limited data, but a wide variety of data. So for overcoming the problem of measurement errors, we shall advise our customers to majorly have someone to take them their measurements. You could get a friend, or in case you have a fashion designer here, you can be able to tell them take your measurements, and then you can put those measurements into the system. Those will be more accurate, and the results that will come out will also be more accurate. We have the differences between accuracy, recall, precision, and F1 score. Accuracy is basically the ratio of correct predictions out of all predictions made by an algorithm. So in case we have only one person whom we are using to determine our data set, that means we are going to be 100% accurate. And then recall, this is the ratio of correctly predicted outcomes to all predictions. And then we have precision. Precision is the ratio of true positives over the sum of false positives and true negatives. Then F1 score, this is the way to measure how much accuracy is present in a data set. The appropriate AI evaluation metrics for my AI projects are majorly going to be recall. Recall is the classification metric used to measure the performance of a model. It also describes as a way of remembering or making insights based on the past. So this will be majorly, we shall get this majorly from the customer's feedback. So in case we have been able to get the customer, the cloth fits perfectly, that means we shall have it like a yes. Because the cloth doesn't fit perfectly, we shall have it no. So based on that information that we have been getting, we shall use the recall precision to measure, to evaluate our system. Then we shall also have the precision as an evaluation matrix from my AI project. It's the value that gives the value of number of times one took the correct action of all times one took the action. So basically, we shall try to go through our data set and be able, for all the cases that you have been working on, for all our customers, were we able to get the right, like were you able to deliver the outfit that fits them perfectly. So we shall have a yes there. And then in case we weren't, we shall have a no there. So that will help us also to predict, to evaluate our system the more. Thanks, that's all I had for you. Please don't forget to like, share, and subscribe on my YouTube channel to get more. Thank you. I remain Monica.